So everybody, welcome to our January PyData Ann Arbor Meetup. I'm Rose Putler. I'm one of the co-organizers of the Ann Arbor PyData Meetup, along with Sean and Ben, who you met downstairs probably if you have not met them before. So I just want to acknowledge our sponsors. So NumFocus, which sponsors the meetup, TD Ameritrade, which sponsors this beautiful space, and Midas, which who provides the food. So a couple of important points. We have emergency exits, both the way you came and through this way. Feel free to provide feedback to the organizers. We have a Twitter and email, and you can talk to any of us afterwards. Our GitHub is here. Slides are usually there. Okay, I was like, this is a new line. And we are in a lovely, lovely borrowed space, so please clean up after yourself. So some notes about Q&A afterwards. So unless quick, hold your questions until the end. Please phrase your question in the form of a question. Try to keep questions to 30 seconds or less. Avoid long statements or monologues. Again, phrase your question in the form of a question. And there will be time for open discussion after the Q&A with the speaker and with everyone else. So keep that in mind. So now I'm going to read the PyData Code of Conduct. So, PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, religion, or experience. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds and levels of experience. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. Thank you for helping make this a welcoming, friendly event for all. So we're going to do a quick icebreaker. So Eric, our speaker, gave us a great icebreaker. So turn to the person next to you, someone you don't know preferably, introduce yourself, and then you get to discuss what you think the best breakfast in Ann Arbor is, particularly for a weekday morning like tomorrow morning, when our speaker will be still here. So. So we'll give you a little bit of time and then we'll call you back together. But best breakfast in Ann Arbor. Go. So hopefully we've solved it. We know the best breakfast in Ann Arbor. And if you have suggestions, feel free to talk to Eric afterwards and make sure that he knows what you think the best breakfast in Ann Arbor is.
We're within walking distance of downtown, right?
Yes.
Exactly. Okay. So this month in data science, Open Source Directions is a podcast hosted by QuanSite. So they highlight different open source projects, especially in data science-based open source projects in their podcast. So go ahead and check that out. Our next event next month will be Amy Hemmeter. And she will be talking about the summarization of news articles using TextRank. So we're excited about that, Amy. So that'll be February 12th, another Wednesday, and same place. We are seeking, we wanted to advertise that they are seeking panelists for a discussion after a movie screening at the Michigan Theater on debugging the gender gap. It sounds like they prefer more than 5 years of experience in tech or software engineering. Particularly, they're looking for a diverse panel. If you have questions or interests, feel free to email Brooke Wolford. Here, it is during our March PyData event. But I'm sure you would be a great contributor to that event. And yeah. any community announcements. So for those who, let me explain first. So, so for those who have not been to PyData before, which there are a fair number of you today, so we have this opportunity to do community announcements for folks who are looking for work, for folks who have work, folks who want to talk about, interesting packages they've released or other things. So this is your opportunity to make an announcement, and folks can talk to you afterwards. So.
Announcement. I'll be the Michigan.
What's your name, Chuck?
Group.
What's your name, Chuck?
I'm Chuck or Charlie. Depends on what you want to call me. We're the Michigan Python User Group is looking for a March 5th main topic speaker. That means it's about a 45-minute or so talk, and there's been recent good attendance. Last time we had a great talk from Brian here, and reach out to the organizer, Dan Y, and Meetup if you were willing to do it. It can be any kind of Python programming.
Great, thanks. Amy.
Speaking of reports Python, he's giving one at the NLP Meetup on February 27th. You can find it on meetup.com. Don't look up NLP, it's a bad algorithm. In Arbor, Detroit NLPers, and that's on February 27th. And Brian is going to be talking about
Talking about how to make sure your neural networks are correct, because a lot of people do it wrong.
Where is it hosted? Is it in Ann Arbor?
it's in Spark.
If anybody's looking for a data science gig out east, I'm recruiting data scientists and operations research folks for a multinational company in New Jersey. My name is Ben.
Thanks.
So I also have a job announcement. My name is Craig Stevenson. I work at a company called Everactive as a data scientist on our data team. We are a growing IoT company with kind of a deep technical play in that we produce a batteryless sensor to monitor various industrial applications. And we're also kind of undertaking more recent developments to vastly improve our data management and architecture practices, both to facilitate more quickly answering business questions, driving insights, and also furthering development on our early failure detection algorithms. That's one of the big business values that we provide to our customers. Another neat thing about our data team is the culture we're trying to promote is something we're calling full stack ownership. So we're very purposefully blurring the lines between scientist and engineer. We want folks who are interested in not only conceptualizing problems and doing exploratory analysis, but also taking those to productionizing or deploying to production. So that's what we see as kind of a neat feature about the data team that we're growing. We're currently a team of 2, myself and Clayton, and we're hiring for a data scientist position. So, anything to add to that?
My face is screwed.
And wait, one more. What was the restaurant we decided was the best breakfast? Angelo's.
Angelo's.
That's, you don't need any other info.
Sit.
That's where
Hi, Kyle. I just moved here. This is my first one in Ann Arbor. I work for a relevant open source project that does data pipeline validation, profiling, and documentation called Great Expectations. So if you want to talk about that after, I'd be happy to.
Any job hunters? Including speakers?
Barry DeSico, statistician, trying to transition to data scientist. So basically got a lot of statistical knowledge, working with people, especially people who are scared, feel pain in statistics. Fair amount of stats experience, modern R, some Python. I'm currently working as the senior SAS programmer at Stratascent through the SAS Institute at Volkswagen Credit. It's one of those things, working for on customer satisfaction, purchase behavior. I'm currently wrapping up my first attempt at text analytics in Python because they didn't have anyone who could do anything. So I decided I should take advantage of doing that.
Great. Any other announcements?
The Ann Arbor R users group will be having a meeting in the second Thursday February. We do not have a speaker. If anyone wants to volunteer, we're open. Right now, if we don't have a speaker, I will talk about using R&R Studio on Amazon Web Services.
Great. Oh,
Hi everyone, I'm Selma Siddiqui, and I'm graduating from U of M with my Master's in Data Science in May. So I will be looking for a job very shortly. Greg and Ben, I might approach you afterwards.
all right. Thank you, everyone. So now, Eric is a data scientist at the Novartis Institutes for Biomedical Research, where he conducts research on machine learning algorithms and their application to early drug discovery programs and builds machine learning systems in support of bench science. He received his PsyD from MIT in 2017 in the Department of Biological Engineering, studying influenza evolution and ecology at a global scale, and was an Insight Health Data Fellow, where he built a flu sequence evolution forecaster as his project. He's also an open source software developer and community educator. And I'm not going to read his website, but I'm sure he will have it on his slides somewhere. So welcome, Eric.
Thanks a lot. First off, I want to say I'm very honored to be here because I heard stories of how there were individuals who either had something at 8 p.m. and decided to like stay on just to be able to catch it. There are other individuals who drove like 53 minutes from another town just to make it here. So on one hand, yeah, it feels like pressure's on. But on the other hand, it also feels great because like I've been a coastal person for most of my life. And so like I've lived on the two coasts of North America, Canada and United States. I lived in Singapore for a long time. And I rarely come to a landlocked area, part of town, part of the country. And so no, I'm used to like this coastal buzz of like all the latest ideas, which I know is like, there are less barriers now, but today for me, it's very eye-opening just to see the community out here and how vibrant it is. So for me, it's an honor. And I think I have to also say, Sean's a great guy. According to some things that he says don't listen to, Sean's a great guy, and I'm glad that I'm able to be here. Okay, so today, when I was thinking about brainstorming a little bit over what might be of value to deliver to the PyData community here, I was thinking mostly along the lines of what's a valuable practice that we might want to encourage, but is not done very often. And so the practice that I decided to talk a little bit about is testing. It's a very simple, easy to get started topic, but we don't talk about it very often. And at least amongst peers who are in other firms, who work at other places, I don't hear much from them about the practice of writing tests as a data scientist. Okay, so I'm going to flash the slides up for the next 10 seconds. If you would like to get a copy of the slides, you actually can just scan the QR code with your iPhone camera and you'll get it. Otherwise, you can read the minuscule text at the bottom. It's testing for data scientists at the bottom, all right? And you will have, I think the CI system has finished building the slides, and so it's up there ready for the latest version that I'm presenting should be up there as well. I don't mind questions during the talk, but I will adhere to the rules set down, so please keep the questions short, but feel free to interrupt me anytime in between. And also, if you end up like browsing through your phone during the talk, I'm just going to assume you're looking at the slides on your phone. Okay? Cool. So just a little bit about myself and where I work before I move on. I work for the Novartis Institutes for Biomedical Research. As Rose mentioned, it's a lot of machine learning. It's a lot of machine learning work. I also happen to just do on one project, happen to play every single role possible. So software engineer, data engineer, CI system, quality, QA testing, everything. It revealed for me why I know it revealed for me a lot of deficiencies in knowledge. Let's just put it that way. I know some stuff about software. I know some stuff about testing. But really the core expertise that I know that I'm competent in is taking a problem, defining it, taking the problem to completion, and then delivering the prototype, and then maybe working with others. No offense against, I actually really love the fact you guys want full ownership of the whole stack, because a lot of projects get lost on the throw over to software engineering or throw over to production. It's just, I also know my limitations, and that's something I need to learn. And thankfully, being dropped into the deep end gives you that learning opportunity. I got into to MIT through the back door and walked out through the front. If you are ever curious about how that worked out, I can talk about it. I'll just take it. Like, walking out through the front door is a good one. And finally, I like Python. It's the first programming language that I really delved deeply into and found that it was friendly to use, community was friendly, packages, ecosystem, very rich, lets me do a lot of stuff in few lines of code. So, and a lot of people give back as well. So I think it's a great community. I also have a lot of friends who use R. My manager uses R. We have a good relationship. Let's leave it there. Okay. So first off, I have a question to pose to you. How many of you would self-identify as a data scientist of some kind? Statisticians included. I don't want to exclude you all, because I believe your work is fundamentally very similar. So then, how many of you write code more than 50 of those who've raised their hand? How many write code in a programming language more than 50% of the time? Okay. And how many of you write tests for code? Of those who had their hands raised. Okay, so not a lot. And so this actually does confirm that my talk today has a purpose, and I'm not just preaching to the choir. Okay, so for those who choose not to write tests, what are the reasons? And I want to be completely non-judgmental here, and I really mean it. What are your reasons for not writing tests? Could we have a few volunteers? First and then second. Time. Okay, big one. Second.
I'm not even sure how to run tests.
Not sure how to get started.
Text analysis, so it's import data, run stuff,
Yep. Okay.
get outcomes.
Got it.
For some of my data science projects, the code is not the deliverable.
The code is not the deliverable.
No, but in cases where the code is deliverable, there is testing.
Okay, cool stuff. And then right behind you.
Usually one-time code.
One-time code. Exactly. Good. Back there.
About test-driven development until late in my career.
Okay, yeah. So sometimes it's a lack of knowledge, and that same thing for me.
Well, I think everybody's kind of said the same thing. Basically, it's not value added for some people's perspective.
Yep.
But the problem is, and my son is a coder, and I told him from day one, I said, the problem with most engineers is they assume that they're getting to an answer, and the answer's correct. There's no reason to test the truth or validity of it.
And we as data people can fall into the same trap.
And I can tell you there's value in understanding why
Yeah.
part is.
Yeah. Absolutely.
I'm lazy and there's more fun stuff.
Whoa.
No, that was very frank, and I again don't want to be judgmental. I have fallen into that trap too myself. So yes. Cool. There's just that, try that other neural network and like forget about that test. It's like not so important. Like, that's interesting. And then of course, now if that was one-time code, I'm not bitten in the butt later. But if that was not one-time code that I needed to write a test for, well, good luck to me. And for those who do write tests, can I ask what are your reasons?
I want to be able to change my code and be confident that it still works.
Mm-hmm. Okay. So you've come to depend on it.
Yeah.
And you need to know that you also can plausibly forecast that you'll need to modify it.
Yes, and when I kept my hand up, I'm only speaking half truth in the sense. So the Java code I've written is well tested because there's a framework I understand for doing those tests.
Mm-hmm.
Anything I do in Python, I don't know how to test it
Yes.
in a systematic way.
Yeah. Okay. Cool. And I saw a few hands there, and then we'll go to the right-hand side after. Bradley.
If you're developing a package, you have obligations to your users that expect things to work.
Yes.
If you're writing it for a project where you're the primary developer and user of your own tools, if you've been bitten once, you sometimes learn a lesson.
Yep. Okay. Okay. And I saw another hand to the left.
I work on projects in an organization where it's a requirement.
It's a requirement. So the someone above said you have to do it, so you do it. Gotcha. The right there?
I want to save time.
You want to save time. Could you elaborate?
Yeah. If you have the test set up, you can program faster, go back. I mean, inevitably, whatever we program first doesn't work perfectly.
Right.
If you're always having to pay super detailed attention to your code, you might move slower. But if you have the test set up, you can quickly iterate.
Gotcha. That's right. I totally agree. And back there, last point. Intellectual property rights. That is actually the first time I've heard this reason. Can you elaborate on that?
For instance, if you develop a neural network that understands people's needs, like for instance, there is an algorithm out there that understands the luxury customer and what they want. If you had a neural network that did something similar, not exactly like that, you want to be able to protect that. It's intellectual property.
Mm-hmm.
You have something that you tested and you know that it's good. So if you put inputs into it, you're confident the answer is correct.
Okay. 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 We'll make 2 exceptions. I saw 2 more hands.
I'm just thinking it's usually a teamwork in a company environment.
Yep.
So you write something, you want somebody else to be able to,
Yep.
to look at it and run with it.
Yeah, absolutely. And
With verified edge cases easy.
yes, yes, absolutely. You need to. Well, it also relates to having confidence about what you're doing, and that you can have confidence that your program or your code handles edge cases correctly. Yes, absolutely. Okay, so apart from IP, all the other reasons are valid reasons that I've heard before, and what I hope happens is that in the discussion afterwards, those of you who haven't written code for maybe not the best reasons, do find others who write, those who don't write tests for maybe not the best reasons, find those who do, and also at the same time, those of you who know the ecosystem for testing in Python. I'm going to allude to it later, but give a talk at PyData and Arbor. Look for Sean, and he'll sign you up to be a speaker. All right, is that correct? Absolutely correct. Okay, great, cool. So today I want to convey a few points. Namely, if you are a self-identified data scientist who is part of the broader data science community, and a big portion of your role is in delivering something that involves code to another team, then investing in writing tests today will bring you all of the benefits that we discussed about just now. Namely, you'll save time later on, you'll decrease team frustration, and you'll increase team productivity. And when I say testing, I really don't mean this only in the sense of only testing. I actually mean this as a broader point with respect to other software engineering skills. Now, I'm not expecting that every data scientist in every single project becomes, writes the most seasoned software engineered code. No. What I'm trying to convey is if we apply some basic software engineering ideas, like writing modular functions that have limited scope, like writing tests, and also writing docs. How many of you write docs? Not very many. I am guilty of that myself. I don't really write docs on some occasions. But if we do adopt these practices, we reap all of these same 3 benefits. And so today I'm just going to focus on testing. Okay, so to convey the message, I'm actually going to tell you about 2 projects that I worked on. One is a hobby project. The other is a project at work. All right? And the first one is how the use of automated testing tools in Python allowed me to reveal weak spots in my code. So before I could even think of the weak spots, automated testing tools revealed them for me. And so then that gave me a lot of confidence in building what I wanted to build. The second one is actually how writing tests for my code as well as for data greatly accelerated a lot of data analysis workflow downstream because we had great confidence in what we had. To borrow the thing that Kyle works on, Great Expectations, I had perfect expectations about what data I was using. Okay, and so this is I want to use these two stories to convey those points. So let's start with my hobby project. It's a project in which I had been hacking on since grad school, and in this project, the goal is given protein sequence, predict drug resistance value. So your data sort of just looks like that. Now, I was interested in this problem in grad school mostly because I was interested in this genotype-phenotype problem. Given a genotype of a virus, predict a clinically relevant phenotype. For those of you who want to try to improve upon this, I don't want to discourage you from trying, but do know that you probably won't make any money out of it because there are commercial systems for this. So this is really a good project to get into machine learning, and if you're in the biosciences, machine learning in the biosciences or life sciences. This is a great project to attempt, but don't have any expectations that you'll make money. So we get data that looks something like this. I got protein sequence, and I want to predict a number. It's as simple as that. There's nothing really complicated. Okay? So you can imagine it's a protein sequence, and machine learning algorithms don't really take in strings. So you have to do some featureization of the sequence. You have to convert that long string into a vector and do it for every single sample that you have. So we might write 3 functions, and I'm just going to give you the rough architecture by the code. It's really, I got a file, I read in the protein sequence from the file, I then featureize the sequence and return the features, and then I take those features and load it into pass them into a scikit-learn model, and then I get back a column vector of numbers. Are we okay with that? So far, so good? Okay, so this is sort of your very run-of-the-mill standard kind of supervised machine learning project. Question to the crowd now. What have we assumed here in this function that you think might plausibly need to be tested? Give it a moment. Actually, talk with your neighbors, another neighbor that you didn't socialize with, over this for about a minute or so. Think about it and talk about it.
What is it? Then there are 5 they have a number that is actually like
Okie dokes. All right. Let's gather back. I wanted to ask if anybody had ideas about things that we're assuming for the first function, the one that I'm highlighting up here. What might we have assumed in this function?
You can find the file.
Okay, that you can find the file. Cool. They're the correct format. Okay. Anything else?
What to do if the file has more than one protein?
Oh, yeah. Okay, cool. Very good. So there are a lot of assumptions that you can see are happening in this first function. And those are all valid. What about the second function? What?
Everything.
Pardon me?
It accepts every output that can be generated by the first function.
Okay, right. Anything else? Ah, okay, very good. Is the what do you call that? The alphabet correct? Anything else?
You can test whether the array that it returns is actually 5 times longer than the sequence you put in.
Okay. Okay. Anything else we're assuming?
The array has correct values. If it's supposed to be letters going in, it's got letters going out.
Oh, it's numbers. My bad. Sorry. I should have numeric. Yep. Okay. All right. We're gonna move on. How about that final one? What have we assumed here?
That features in a biological sense would actually be something that could be used for some of these standard models.
Okay. Yep. Anything else?
That model's been trained on the same features that you're.
Yep. Yep. Okay. Anything else? Valid point. Yes.
That it's the current version of the model?
Okay. Yep. That's right. So especially when we're going into a production system, that's something we want to think about back there. Yes, that as well. Okay. And final one back there.
And he brings up a good point. And I was going to say, even from the standpoint of input information, is it statistically normal?
Yes. Okay. Cool. Very good. So, as I'm discovering slowly, everybody here does have the instinct. We all actually do have these instincts. So my hypothesis, which I'm going to throw out, is that most of us don't write tests because we are lacking time. I think that's the primary reason. And the other is that we know we don't depend on it, but then the primary one is primary drivers for work. We don't have time. But anyways, let's come back to what we want to test. So in this particular example, I'm going to focus mostly on the last two functions, right? And it's partly because of time, partly because it's the easiest to sort of grok, all right? So, pardon me?
What does grok mean?
Sorry, to grasp, okay? So first off, let's write a test for featureize. Now, for those of you who are not familiar with the testing machinery in the Python world, there's a package called PyTest, and it lets you write functions that are declarative of your tests. So in order to test the function featureize, you would import the function featureize from wherever your library is. Then you would write a function that is called test underscore some informative name. And inside there, you place all of your tests. Effectively, what PyTest is doing is eliminating away a lot of the boilerplate code that you might alternatively write if you were to use the built-in unit test framework. Now, if you're in this scenario where you can't install packages, use the unit test framework. If you're in a scenario where you can, I would strongly recommend that you use the PyTest framework for testing because it provides a lot of conveniences. And it also has a rich ecosystem of extensions that I'm not going to talk about today, but I want to keep your appetites whetted. Okay, so how would we write it? We might say, let's input something that is a known valid example. So let's take a known HIV protein protease sequence, stick it inside here, pass it through feats, and then assert some properties of that of the output. Okay, and so that's something that we might choose to do. We can also do a test for the function predict. Okay, in this case, I've only chosen to do a simple execution test, or just run the code kind of a test. This is if you are in a hurry. This example-based execution test is by far the simplest test that you can write. You actually, if you are testing interactively in a Jupyter notebook, you are doing execution tests all the time. Does that make sense? So if you do that, just copy and paste that block of code into a test and execute it, unless of course it takes a long time to run. But if nothing else, this is the bare minimum. So I've sort of hinted, are we done with this function then? With this test? Clearly not, okay? So as some of you mentioned, the input to the machine learning model is an array or a matrix that is of width 5 times the length of the protein sequence. Okay? So focusing on just this one particular problem, if I passed in a sequence that was less than the sequence length that the model was trained on, I'm going to get something that's less than 5 times the length of that HIV protease. In the case of HIV protease, which is what this one's for, it's always 495 long vectors. So I pass in something, because it's 99 amino acids long. If I pass in something that's 98, I'm going to get an invalid input. If I pass in something that's 100, I'm still going to get an invalid input. So in order for the model to work, I need to ensure that my input to the model is 495 is a 495 long vector. I also therefore need to make sure that the input to the featureize function is a 99 long string at the minimum. And I deliberately phrased it that way because in the featureize function, you can also have invalid inputs. There are, as someone mentioned at the back, invalid amino acid letters. O is not a letter in the amino acid alphabet. And so if I were to pass in a string that has the letter O, it should crash the program, right? So first off, if the user inputs a string for this project, if a user inputs a string that's not 99 letters long, the program should crash. And if a user inputs a string with invalid characters, something that's not drawn from the 22 defined letters for the amino acid alphabet, or 24. I can't remember. It's one of the two. There are ambiguous characters that are allowed, and there's a special asterisk character that is also allowed. If you're not amongst this set of characters, the program should also crash, right? So let's try first by making the code a little bit more robust, okay? So first off, we can say, we can declare a test that looks something like this. First off, I first declare what the acceptable letters here. In this case, I'm deliberately omitting the asterisk because I don't expect it to be present. We then take, even though it is one of the valid characters, I'm designing the program not to just ignore it. We have the featureize function. And we can do a few checks because we know this featureize function is something that the machine learning model depends on. We therefore bake in some checks, hard checks over here. The length of the sequence must be 99 long, and the set of characters that are present inside the sequence must be a subset of the acceptable characters. And then, and only then, do we do stuff to featureize, okay? So then once we have this, we can actually make the test more robust as well. And so how would we do this? This is where I'm going to introduce a few concepts simultaneously. So firstly, you can use PyTest to check that a program errors out correctly. Right? You can use PyTest to check that a program errors out correctly. And the way that you do that is to use this with pytest.raises syntax, which allows you to say, which allows you to declare, I expect that featureizing this sequence, if the sequence is not 99 long, to raise a value error, which I had previously declared in the function. The second thing that I'm going to introduce here is that you can actually use a generator, an automatic generator of test examples that comes from the library Hypothesis. And how many of you have heard of Hypothesis before? It's a very, very good library for generating all sorts of test data that you might want to pass into your test functions. Okay? You can generate strings. You can generate all the Python primitives. So strings, lists of stuff, tuples of stuffs, dictionaries of stuff, nested data structures. That's all possible. Guess what I also found out? You can generate NumPy arrays. You can also generate pandas data frames, which is amazing, right? If you think about it, I can declare what data are supposed to look like in my data frame and make sure that the functions that operate on data frames operate exactly as I want. So I can say, using Hypothesis and its and its decorators that are compatible with PyTest, I can declare that this function should be given as part of the sequence argument text that is drawn from the acceptable letters alphabet, and I'll just, for convenience, hard code stuff that are within the correct bounds or most expected bounds. Okay, and so with this simple syntax that I can start to declare what kind of data I want passed into this function to test it. Okay, so you'll notice I deliberately I'll get there. I ignored the invalid character example for the time being, but you would use the exact same thing, except in this case, replace the alphabet with something that comes from the full suite of characters. Okay, so you can generate all of these examples very, very quickly in an automatic fashion.
Is the given generating the inputs combinatorically or randomly?
It is generating random inputs, but so I think I misunderstood the question. Your question is, if I had two arguments and two things that I wanted to pass in, right? Then would they be considered independent and therefore generated combinatorially, or is it? Yes.
You said the minimum size is 0 and the maximum size is 200. Am I testing a 0-length string and a 1-length string and every length string up to 200, or am I randomly generating something between 0 and 200?
It is the latter. Yep. So you don't necessarily have to cover the full parameter space. Okay.
So is that given like tightly coupled with the test that comes after? Or
Yes.
Okay.
It is part of the Python decorator syntax. So the given function modifies this function and does some other magic stuff. Okay. But then, it reads well. So you're saying this function should be given a certain set of stuff. Sean?
Related to that question, does it matter whether the generated inputs are deterministic for reproducibility purposes?
I think this is a little bit out of my realm of current knowledge, but I think it is possible to make them deterministic. One thing that Hypothesis does is it intentionally shrinks your examples to find examples that break your code, minimal examples that break your code. Okay, and I'm sort of letting the conclusion out of the bag. Everything that I'm going to talk through over here is the ideal way to discover, to write your tests. In reality, I use Hypothesis to brute force my way to finding all the edge cases that I never would have thought of because I'm too lazy to think of them, right? And so Hypothesis will find them. And it makes me much more clearer about the code that I write. Okay, so we're now, with that one function better tested, we're in a little bit of a better position, right? That function now has become something reliable. Question, yes? No problem.
I assume it has to run more than once.
Yes.
And do you specify what's the maximum number to run, or it's just up to Hypothesis to decide?
Hypothesis has a default, I think, of a few hundred examples that it will generate. So it's doing a lot of stuff for you. And in some respects, you can think about the old way of testing where we have an example-based execution test. Well, example-based test is being like automatic manual testing. I have to declare certain types of certain examples, right? That's automatic manual testing. So if you watch the tutorials at PyCon on one of them being Escape Auto Manual Testing with Hypothesis by Zach Hadfield, I forgot his surname, but he's from Australia. He's got a conjugated surname, and so I can't remember at this moment. But Zach is the guy one of the people who maintains the Hypothesis library, and he has a full-on tutorial about that. So I would strongly recommend that you check it out. Okay.
Is there a reason you were doing it this way versus using try and accept blocks?
I think it's for future me to be able to read it more than anything else. And I mostly write code defensively against future amnesia. That's how I write my code. So it's got to be easy to read. Okay, so we're in a little bit of a better position. The function as it stands defends against unexpected inputs. So we have some defensive programming happening. The tests will help us catch breaking changes. And if you hand this over to your engineers who are going to take things into production, or if you hand this to your future self 6 months while you're taking it into production, then you're going to thank yourself, or your engineers are going to thank you for writing robust code. Okay? So I know it is not every team will have the opportunity to take the thing to production. Not every project will end up like that. But if you do it for the projects that you know are going to go to production, then you've written robust code for production purposes. If you try to do it to the best of your ability on projects that are not in production, you have gained practice and experience writing better and better and better tests. Okay, so that's my word of encouragement for this little bit here. So, like I mentioned just now, I actually used hypothesis to instead brute force my way to all of the invalid inputs, found all the invalid inputs, made the code more robust, and then continued iteratively. So you can use hypothesis both as a library for just brute force testing, but also for figuring out where your most obvious bugs might occur. Okay, so it's a great library. Writing tests, in short, also helps you catch bugs. Cool. Now, the other story that I want to talk about comes from my work, which is the development of a protein engineering platform at work. We're doing enzyme evolution. I am part of the 3-person computation informatics team that is supporting this platform development. And so in this protein engineering platform, we're writing lots of code, but it's a relatively simple code base. There's lots of independent utilities that we have to write with some function sharing. And because I already did talk about testing functions, I'm actually not going to talk about that in this example. I'm going to focus on data. I'm going to talk about writing tests for your data. And I think it's important. Okay? So our data, because we are in the development phase of the platform, and we're developing assays, the assays will change from enzyme to enzyme. We're therefore faced with this complex evolving data sort of requirements, right? I can set up a database for one enzyme. I'm probably going to have to ditch that database if we have a new enzyme to load data, unless I structure things correctly. So basically, as the platform gets built out, there's a lot of things that are evolving. Sometimes as scientists, we'll say, oh yeah, this is the way we want to calculate it. And then 3 weeks later, we realize, that really wasn't the way we should calculate the activity of the enzyme. We need to use a different math equation, so the output that we're interested in changes underneath us. Okay, so that's how these data requirements change. And we do try to normalize the database as far as possible to the best that our tiny little data scientist brains can understand what database admins do. But yeah, it's complex, and we found ourselves in this place where, to get to the place where we wanted just the data that we wanted, human readable, easily parsable, we had to do all these crazy joins. Okay, it was not fun. How many of you have maintained 30-line SQL joins to create your database views? Yeah, and when things change, you have to run back up the chain. If something really way upstream changes, you have to propagate them slowly down to the final view. It was not fun. So what we ended up deciding was we're going to ditch all of our views because we're not going to do this. We made some intentional choices because we're not going to do this database management thing long term. IT is going to help us. For the development phase, we'll just cache the raw data and use pandas to do our joins and define all of our joins in pandas code, rather than worry about SQL joins and maintaining things and wrestling for hours each time to update the joins, right? Okay, so that's what we ended up doing. So yeah, if you update and maintain a 30-line SQL view, you end up with this face, right? Pretty often. So instead, caching pandas data frames was the right thing to do. Sorry, I have these puns I really like. Okay, so the problem here is that if you work with Python packages, you know how important the API is. There's a reason why I have a slight distaste for the tensor packages that have been developed, because they don't respect the NumPy API, which is extremely idiomatic. Likewise, I've had friends, colleagues, ex-colleagues who, in their other jobs, encountered data analysts who willy-nilly changed the schema names, going from capital letter to lowercase and the likes. And I said, Andy, you got to write tests for your data, man. And that's when this really started showing up as like a real consequence that someone might have to deal with, because all of Andy's production systems were broken by a capitalization change. So yeah, your schema is the API to the data. Now we can have debates about whether you want to access the schema directly or you want to have like API access, data access layers or not. That's a choice you make, but then whatever it is, your schema is the data's API. It has got to be stable, or if changes happen, they have to be caught as early as possible before anything in production fails. Okay, so yeah, if the schema changes even slightly, we want to know this ASAP. So how do you then write tests for data? I'm going to give you one example. This is not by no means ever the most authoritative example, but if you really need to get up really quickly without using highly engineered frameworks or libraries to do it, and you just need to have something quick and dirty, here's how you can do it. So you might want to test some things. You want to check that your column names are correct. Sometimes you might want to also check that your row indices follow some order. You want to check your column data types. You want to check that what you expect to not have any null values are actually not null. Okay? You want to check that the bounds of your data are correct. You don't want to have, if something is supposed to range from 0 to 200 and you get a -999, who was that data analyst who? Yes, okay. Can you think of any more beyond what these examples that I've listed? Yep, okay, so you want to make sure that your distributions, if your predictions depend on a particular distribution of data, that distribution of data should remain the same, okay? Anything else?
Duplicates and kind of updates.
Okay, you want to make sure that there are no duplicates where there are not supposed to be any duplicates. Okay, anything else? The syntax of your queries. Now that assumes we use SQL, but yes, absolutely. Yes, when you do, what do you call that? In SQL land, you call those like foreign key referencing, right? Yeah, you want to make sure that that's all correct as well. Anything else? If not, I think we pretty much covered it. So an example of a very lightweight example of how you can get tests written for your data is to do something like this. You query your data and you explicitly write your tests that way. Okay, that's one way of getting up to speed. Now, Kyle here works on Great Expectations, and I actually deleted the slide, but I still wanted to mention it. Like, the only thing that has stopped me from using Great Expectations at work is time, which is exactly the same reason why some of us don't write tests, time. And that if you look through how Great Expectations work, it's a little bit complex in getting set up, but there are easy entry points into it. You can use that to declare some of these tests in much more readable declarative fashion. It has these test functions that go assert or expect that this column is not null or something like that. Okay, it's got this very nice syntax that in plain English function names tells you what you're expecting about your data, which is, I think, where the name of the package comes from, right? Yeah, Great Expectations.
And
some novels.
Charles Dickens.
There we go. So yes. So it is another package to check out. Okay. Now I wanted to talk a little bit then about how tests accelerated our workflow. Okay. We use data caching. So we cache like once a week. We pull down the latest data onto our local machine because we know we're not going to maintain that database long term, but we still need to use it to prove it. So okay, we cache the data. We write some tests for the data. If you remember, like I had mentioned earlier, there were times where we were changing the SQL views because of instability in our upstream data. We ended up spending hours on this, right? But when we got the views correct, when we got the views correct instead in Pandas code, we could just look at the output data and say, this I know is correct, and we start writing code against it. We actually built on top of that. So we have all these custom queries that come in. Sometimes if I didn't have the right view in place, I could spend hours writing another view in SQL to try to get it right. Whereas instead, in Pandas code, which is merely a language that I just understand better than SQL, in Pandas code, I had that function in a matter of mere minutes, right? So think about saving hours of a day going to get the data that you actually need because you had great confidence and great expectations, perfect expectations about the data that you were handling, okay? Now, of course, the way to have absolutely perfect expectations is to never have the schema change under you, right? So fight back against the data analyst who changes the capitalization of your column names. Okay, so we took like a 10-minute time. Me and my intern in Basel, we pair coded remotely. I wrote the function in a notebook sharing screen, and at the end of it, it was actually not me who realized that we might have taken hours. It was him, because he had been wrestling with views for a long time, and he at one point said, "Wow, we might have taken the whole afternoon to just get this correct." And here we are with the chart in 10 minutes. So go figure. Tests were great, and it really accelerated the workflow. Okay, so I'm going to wrap up with a few points on how to build out the regular practice of testing, especially if you're in a data science team that doesn't have an existing culture for it. So the first one is borrowed from Novartis's latest millennial craze of being #unbossed. Okay, go watch some videos on YouTube about like our CEO talking about unbossing and culture and all of that. But I really believe in this one because I do that with my boss a lot. Being unbossed really just means take the initiative. So if you don't want to, if you don't want the pushback and you don't want to have to ask permission, but ask for forgiveness. That's really what it's all about. Okay, so go out and build stuff that make it easy for yourself as well as for others to write these tests. Go push your DevOps team. Every company is going to have a slightly different DevOps setup. DevOps are extremely crucial to getting the culture of testing going. When I mean DevOps, really all I'm talking about is the continuous integration systems that automatically test your project code base on every single commit. You want that in place. You don't want like humans hitting make test from your make file, right? You want a system that just does it so you don't even have to think about it. So go build the CI systems, knock on the door of your DevOps team, tell them you need help setting it up. If you don't know how to do it, they'll guide you through it. Write tests, learn how to do the manual testing first, and then automate all of that away, all right? Which brings me on to that next thing. You automate everything. You don't do auto manual testing with your examples. Automate the generation of examples. Don't do Jupyter Notebook-based testing where you just sort of visually inspect the output. Think carefully. If you want to build the culture of testing, you need to make things really convenient. So set up the CI system. Adopt workflows that also prevent code from being merged untested, especially if this is not your fun project at work, but something that someone is going to depend on, okay? Finally, building credibility is important because I know there is going to be the human factor. I was talking with Sean this afternoon about like how hard is it to change things, right? In the culture of change, humans are like the biggest barrier. It's not tech, it's humans. So you need to build the credibility with others that say changing up a little bit the way that we do our science is going to have much greater benefits even if they are invisible at the moment. They are going to have dividends paid off way down the road with engineering teams being happy to work with data science teams, if that's the setup at your firm, with your future self being able to accelerate your work later on because you invested in a lot of automation and testing. So build the credibility. If you notice a benefit, write to your DevOps team a blog post, an internal blog post or an email or whatever. DevOps teams have a hard job and they get bashed quite often, at least in Arbor, if some system fails. So they're always happy to hear of success stories. And if it comes from left field, in a team that isn't expected to use DevOps tooling, but is, now that adds to the joy of their work. And finally, Deliver talks about testing. Okay? Cool. So, some conclusions. You depend on data or code, write tests for it. These 3 lines sort of remind me of some Beyonce songs that we'll pass on that. Okay, some resources that are available on the slide if you want to get started. And finally, happy testing. Thank you very much.
We have some time for some questions.
So you mentioned that testing might take a little bit of time up front, but the benefits pay out later.
Mm-hmm.
And the benefits are greater than the time you invested up front.
Yeah.
But in a lot of research contexts, at the very front, what you're doing is essentially prototyping.
Yeah.
9 out of your 10 implementations you might end up throwing away.
Yep.
So do you invest the time in testing all of those 9 out of 10, knowing that 9 out of 10 are never going to pay back?
Right. Only 2 out of 10 do I test.
Only 2 out of 10.
And it's purely for the practice of getting familiar with the tooling and not over-investing. So I totally agree with like the time investment is not something you want to waste, right? So at least for myself, the usual decision point for writing a function and therefore a test is I've copy and pasted that block of code more than once, right? And so then once I know, oh crap, I'm going to depend on this block of code, that's when I actually go and write a test just for that little piece of code. The full pipeline where I'm prototyping, like I actually don't write tests for the full analysis pipeline until I know an engineer is going to use it.
Am I a good person if my code is not 100% covered by testing?
Yes.
Can you repeat the question?
Yes. So the question is, am I a good person if my code is not 100% tested? Yes. You have intrinsic value as a human being. On a more serious note, even the packages that I've built that are open source are not 100% tested. So it's really hard to do testing at a confidence level of 100%. Statisticians, please pardon the pun. So it is much easier, of course, to be able to say, well, okay, I'll test to the extent that I can. And as soon as I catch a bug, we'll write a test that we'll modify the function and write a test that explicitly brings out that bug and makes sure that we don't ever encounter that bug anymore. So that has happened at least 3 or 4 times in the protein engineering project that I'm working on. Anything else?
Kind of building on his question, with code you can get to 100% testing by measuring lines of code.
Mm-hmm.
Is there any good practice for like data models where the assumptions might not be clear from just code? That you're testing 100% of what the model.
Okay, so the question here is, code is easy to measure in terms of coverage, even though example coverage may not be 100%. Lines of code coverage can be 100%. How do we do that for data? And for that, I'm going to ask for help from Kyle. I'm wondering if you have any ideas on this, because I haven't thought deeply about this.
I admittedly missed the question.
Okay. So how would you measure data coverage?
Oh man, that's a big question.
Yeah.
I can't answer that quickly.
Okay, no problem. I'm sure it's a great discussion question afterwards.
Yeah, definitely.
Yeah.
People definitely are tackling that in the Slack channel a lot.
Okay.
In the Great Expectations, it's pretty active.
Okay.
People want to jump in on that part of the conversation.
Okie dokes. Do you have a preview of like what ideas have at least been thrown out?
I can't off the top of my head.
Okay, no worries.
Sorry.
All right. Thanks a lot, though. Thanks for the help. I had a question up front, and then back there, and then there.
So I just wondered, like, so you're talking about debugging a change in the views.
Yes.
And then sort of shifting
Oh
all
my
that to
gosh,
the
yes.
pandas. I mean, if it was hard to understand what was going on in the views, wouldn't it also be hard to understand what's going on in pandas? And
Yes.
if not for you, then for the next person?
Yes. And so if the view itself is complicated, we do try to modularize what we're doing and declare in our comments of the docstring of the function that creates like the intermediate views, we declare where we intend this function, like the output of this function to be used. And I have found myself explicitly naming this output is expected to be used in that next function. So, and it just provides the contextual link between those functions.
So
now,
that was the naming and the documenting and the testing.
yes, yes, it is absolutely that. I don't know how to do this, but I've never been able to successfully comment and document my SQL views when they live all on the server and not in my code base, right? And that makes it a lot more difficult to maintain. Okay, so I had another question behind.
Wondering if you had any kind of framework you like to use for testing model outputs.
Okay, so frameworks for testing model outputs. Model outputs look like data. So if your model output function is wrapped in such a way that you return a pandas data frame, you can use Great Expectations for this purpose. If you don't, you can use, I guess, PyTest machinery to at least do some first pass testing in place. So yeah, you're probably thinking about, oh, the model, does it predict an unreasonably high number, for example, given some certain data, or some impossibly low number, that sort of thing, right? Yeah, so that's what I would approach, how to approach it.
It's just a comment about, for the gentleman who asked about checking the data.
Yes.
I think you alluded to when you do quick check style checks tests, that could be used for testing the model.
Okay, so actually I'm...
Increase the space of your quick check, like hypothesis.
Okay.
Expand a lot of your data.
Yes, so yes, checking data, well, okay, so so the comment was that we can use hypothesis-style tests to test our data. I'm not 100% sure how to do it on the spot, but it sounds plausible to me. It sounds plausible, but I'm not sure how I would like live code it in this moment.
Maybe one last question. All right, with that, I've certainly learned a lot. I'm certainly also guilty of being lazy. Right?
We all have our moments.
But I appreciate that Eric took the time to share some of his thoughts on testing, especially in the data science space.
Yeah.
And so with that, let's thank Eric again for a great talk.
Thanks a lot. Thanks, John.